Hi everyone, welcome to video lesson 13.2. The first half of this lesson we'll be talking about volume of pyramids, and the second half we're going to be talking about the volume of cones. So 13.2 is the volume of pyramids and cones. First of all, the pyramid. Yesterday we looked at the prism, and to find the volume of a prism, it's the area of the base times the height of the prism. So now I ask you this question: with a pyramid that has a congruent base as a prism and an equal height as a prism, how many pyramids fit into a prism? The answer is 3. There are 3 pyramids that fit into a prism with an equal height and a congruent base. So this is 3 times larger. Or if we think about the pyramid is 1/3 the size of a prism. So if the volume of a prism is the area of the base times the height, then the volume of a pyramid is 1/3 of that. So this is the formula that you could write in your notes, everybody. The volume of a pyramid is 1/3 the area of the base times the height. Okay? So if you look at this first one, it is a pyramid. It's a hexagonal pyramid. To find the volume is 1/3 of a prism. And the prism is the area of the base times the height. So what we're going to do here, we kind of have everything that we need. The volume equals 1/3. The area of the base is a regular hexagon. So if it's a regular hexagon, the formula for a hexagon is 1/2 perimeter times apothem. The apothem, it tells us right here, is this 5.2 distance. The apothem is the distance from the center of a regular polygon perpendicular to a side. So 5.2 is the apothem. And then the perimeter, each side of the hexagon is 6 units long. So 6 times 6 is 36. So what I put in brackets right there, that's the area of the base. And then the height of the pyramid is this 11 kilometers right here. So what is the volume? How many cubic kilometers fit inside this pyramid? It is 1/3 times the area of the base times the hexagon times the height. So if you went in your calculator and you multiplied all these numbers times each other, maybe you could practice that on your own right now, you would get the volume to equal 286. 286 cubic kilometers fit inside that pyramid. 286. Let's ramp up the rigor a little bit. It says find the volume of this rectangular pyramid. Well, to find the volume of a pyramid, it is 1/3 the area of the base times the height. Well, the area of the base should be pretty simple. It's a rectangle. So a rectangle, to find the area of a rectangle, it's just base times height. So it's just 2 times 4. That's easy enough, right? The volume equals 1/3 the area of the base, which is 2 times 4, multiplied by the height. So everybody, we got to find this distance right here. That is our height. Some people think it's 10. It is not 10. 10 is an edge of the pyramid, but it's not the height. So we have to calculate the height. So here's how I would suggest doing this one. We kind of have to do it in 2 different steps. If you take this triangular face right here, okay, and if I were to draw the slant height on this, the slant height would kind of go down like this. Hopefully you can see that. I might draw that as a separate picture just so that you can see it better. We have a isosceles triangle on this side where this is 2, the edge is 10, and the height of the triangle right here is the slant height of the pyramid. Okay, I'm going to put L right here, and L means slant height. So I'm going to find this distance L by using the Pythagorean theorem. So we would have L squared plus, right here is the right triangle that I'm talking about. So this distance is 1. So L squared plus 1 squared equals 10 squared. The reason why this distance is 1 is because obviously it's half of the whole base of the triangle, which is 2. Okay, so L squared plus 1 squared equals 10 squared. So solving for the slant height, L squared plus 1 equals 100. Subtract 1, L squared equals 99. and then I'm going to square root both sides. So the slant height is the square root of 99. We could reduce this to make it a reduced radical, but I'm not going to do that right now, and I'll show you why in just one moment. So if we needed to find the surface area, we have the slant height, which is important for the surface area. It is square root 99. So now if I could, hopefully you can kind of see this. Now if I know that this distance is square root 99, I am going to make this right triangle to find the height of the pyramid. And that's what I need to find because the height is what goes in right here. Okay? So again, I'm just going to kind of draw this off to the side. It's this red right triangle inside my pyramid. We just found this distance to be square root 99, and that is the hypotenuse. This distance right here, that's half of 4, so it would be 2 units. And the height right here is what we need to find. So now we can use the Pythagorean theorem again to find the height. So we'll do that right over here. H squared plus 2 squared equals root 99 squared. So now I would have h squared plus 4 equals, and here's why I didn't reduce the radical. What's root 99 times root 99? It just becomes 99. So now that we have this, we can subtract 4, and height squared equals 95 when you subtract 4. And now we're going to square root both sides. So all that work to find the height of my pyramid, and the height is the square root of 95 units. And this radical cannot break down, cannot be reduced. So the height is root 95. And that is what goes in right here. So we had to use the Pythagorean theorem 2 different times. When you have an edge of a pyramid, you have to use the Pythagorean theorem twice in order to find the height. Now, everybody, we can take 1/3 times 2 times 4. 2 times 4 is 8, and 1/3 of 8 is simply 8/3. So 8/3 times the square root of 95, that would be an exact answer, and that would be in cubic feet. Or, as always, if we wanted to approximate 8/3 times square root 95, you could put that in your calculator, and you would get 25.99. 25.99 approximately feet cubed. All right, hopefully pyramids make sense, and if pyramids made sense to you, then I think cones should especially make sense, because the concept is the exact same. If we have an equal height of a cylinder and a cone, and an equal radius for a cylinder and a cone, how many cones will fit into a cylinder? Well, you can see this orange cone, I put it into a cylinder, and let's say it was a liquid, it would then level out and it would look like this. Now I'm going to put this orangish cone inside the cylinder, and as it would flat out, it would look like this. And now as I put this blue cone into the cylinder, it would level out and it would look like this. So again, there are 1, 2, 3 cones that fit into one cylinder. So a cylinder with an equal base and an equal height is 3 times bigger than a cone. Or our formula would then be, again, 1/3. The volume of a cone is 1/3 of a cylinder. And remember what the base of a cylinder is. It's a circle, so it's pi r squared. So really what you could write down, the volume of a cone is 1/3 pi r squared times the height. Because this is the area of the base. 1/3 the area of the base times the height. All right, let's apply this in 2 different problems. Find the volume of this cone. Well, whenever it says find the volume of a cone, I have a formula for that. It is 1/3 of a cylinder. 1/3 pi r squared times the height. So all I got to find is the radius and find the height. I know that I have the hypotenuse, or I have the slant height of the cone. It's 18. And if I have the hypotenuse of this right triangle, I could find the radius and the height, because this would be a what kind of a triangle, everybody? Yes, it would be a 30, 60, 90 right triangle. So to go from the hypotenuse to the side that's opposite the 30, it's half as much. So now I know my radius is 9. And then to go from my side that's opposite the 30 to the side opposite the 60, I multiply by root 3. So the height of my cone is 9 times the square root of 3. Now I have everything I need. Let's put it into my equation. 1/3 pi radius squared. Radius squared is 9. Multiplied by the height, and the height is 9 root 3. So in an exact answer, an exact cubic feet, 9 times 9 is 81. And then 81 times 9, and then that times 1/3, you end up getting 243. The volume equals 243 times pi times the square root of 3. Again, 9 times 9 is 81. 81 times 9, and that times 1/3 becomes 243. And we still have our pi symbol in there, and we still have the square root of 3 that we haven't multiplied by yet. So this would be our exact answer in cubic feet. And then as always, let's approximate this. So let's take 243 times pi times root 3, and then you would get 1,322.26 cubic feet. All right, our last one for the day. This one, it tells us what the volume of the cone is. We want to find the diameter of the base. So if we know the volume of a cone, the formula is 1/3 pi r squared h. And we know that 351 is the volume. So 351 pi, excuse me for missaying that earlier, the volume is 351 pi. That equals 1/3 pi r squared times the height of the cone. The height of the cone is 13. Let's start solving, shall we, everybody? I love it when this gives us in terms of pi, because if we divide both sides by pi, it makes our life so easy. I'm also going to divide by 13 at this point. So 351 divided by 13, that number is 27. So 27, that equals, I still have a 1/3 on the right side of the equation, and I still have an r squared on the right side of the equation. That equals 1/3 r squared. I'm going to multiply both sides by 3 to get rid of the 1/3. So when I take 27 times 3, I get 81. And that equals my radius squared. So to get r, I square root, and my radius is 9 units, and our units are centimeters? Yes. Our radius is 9 centimeters. And our question asked, what is the diameter? Well, obviously, it's double the radius. So our diameter is 18 centimeters. There's your lesson on cones and pyramids. They are 1/3 the size of their cousins, the prism and the cylinder. Let me know if you have any questions when you get to class tomorrow.